Alright, Claire, this one's on logs. This may take us a while to get through this one. So here, I have log to the base 5 of x is equal to 2. What I need to remember, Claire, is that the log is always the exponent. So I say the log is the exponent. So this 5 here is my base. So that's the key. So it's the base of this log, right? So it's like the base of the statue of logs here. And then it's also the base when it comes time to rewriting it as an exponent. So when I rewrite this as an exponent, I get 5. And then the log is the, is the exponent. So that becomes the exponent when I rewrite it. And it's equal to whatever I have left, and in this case all I have left is an x. So I said, 25 is equal to x. So that's kind of the key to it. So let's go ahead and do one more here. So let's say I had log to the base second of 16 is equal to x. I do the same thing, right? So the 2, right, is my base. It doesn't matter if it's in log, which form it is. It's my base. So I say 2. And then the log is the exponent. So this time my exponent is going to be x. And it's equal to whatever I have left. In this case, that's 16. So I come over here, and that's equal to 16. So 2 to the x is equal to 2 to the 4th, and x is equal to 4 then. So there you go. So that's what that works out to be. So that's key. And then the other things I need to remember are the following, that a log is simply an exponent. So if I have the log, of to the base 10, let's say, just for simplicity's case, of a times b, right? That's the same thing. So the log is the exponent. So this is, this is the same thing as saying the log to the base 10 of a plus the log to the base 10 of b. All right? So, once again, if I had, 10 to the a plus 10 to the b, right? I'm sorry, that's not what I want to say. Hold on. Yeah, let me erase that. I want to say it a little bit different than I want to say. 10 to the a plus b, right, is the same thing as saying 10 to the a times 10 to the b. So just giving a and b numbers, if I had, if I had 10 to the third times 10 to the second, right, that's equal to 10 to the 3 plus 2, or 10 to the 5th, right? So this would be, right, 10, 10, 10, and this guy's 10, 10, right, and I end up with 10 to the 5th. Okay, so there's that, and then, all right.
Do nothing to hurt any part of you. Go.
So, Mom? Where's the bug spray?
I don't know. Okay, so let's say I have 10 to the 5th over 10 to the 3rd, right? So that gives me 10 to the 5 minus 3, or 10 to the 2nd. So, therefore, if I had the log to the base 10 of, 5 over 3, that's going to be log to the base 10 of 5 minus log. That's a minus sign. Log to the base 10 of 3. There you go. All right, so now let's go ahead and take a look at that problem. So those are the two, like those rules are really important. They're the rule, power, So if I have log to the base 5, this is the problem you actually gave me, of 17 to the mr, right? I'm multiplying those. So when I multiply exponents, it's the same thing as adding them. So this is log to the base 5 of 17 plus log to the base 5 of m plus log to the base 5 of r. Alright, and if I had been given, let me just log, so that's the problem you actually asked me. There's the answer. Let's do, if I had log to the base 5 of 2a over 3b, right? I could say that this is log to the base 5 of 2 plus log to the base 5 of a, so those get multiplied, minus, I'm going to write it down here, log to the base 5 of 3 minus log to the base 5 of b. So I subtract those terms, right? And these, so let's see here. These two terms, because they're multiplied, right, get added. And then these two terms, since they're divided, we subtract them. All right, and that's it. Okay, so let's go ahead and do another one. Problem. All right, so this is just the distance formula. You could have looked it up on, the internet. It's a version sort of the Pythagorean. It is a version of the Pythagorean theorem, and I end up with x1 minus x2 squared plus y1 minus y2 squared. And I take the square root of that, and that gives me the distance between 2 points. So, for instance, if I had the point, -1, 3, and then this is this is, let's say, positive 2, comma, negative 2, I just plug those in. So this is, x1, y1, right? And this is x2, y2. So, I plug it into the formula. Away I go. And it's equal to the square root of -1 minus 2, the quantity squared. So once again, x1, x2. And then plus, and this is going to be, y1, y2, so I can plug those in, and I end up with 3 minus -2, the quantity squared. So that gives me the square root of -3 squared plus, and this gives me 5 squared. So that gives me the square root of 9 plus 25, so I end up with the square root of 34, and that's what the distance formula is. Okay? Alrighty, finishes that one.